Yeah. I just got a test full of problems, really need to solve them. My head is kinda spinning, you can say that it's revolving. Can't find the sign or tan, so you know that I am stalling. Could say my math grade's falling, yeah boy it's falling. I watched as everybody passed a class, but I didn't and received a D. I really wish I had not slept through trigonometry, but I did, so now I'm really screwed. Ask me to find a side and I won't know what to do. I'm sitting in class, all depressed, I got the blues. Sine A is opposite over hypotenuse. Really need a can't find this angle. Give me some trig and I'll certainly get tangled up in this madness. Didn't even study, stuck on this problem. Wish that I could ask a buddy. That would be cheating, my teacher would be enraged. Only way to pass, so I'll scope answers off his page.
They can't help it and I can't.
This lesson is going to be on the unit circle, and the first thing you'll have to do is draw a circle and learn how to divide it up into different number of degrees and radian measures. Now, degrees are how big an angle is. Radians are how far you would travel along the circumference of the circle. And you know from geometry that the circumference of a circle is 2 pi. You also know from geometry that the number of degrees in a circle is 360 degrees. So if I were to count around this circle, I would go 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. If I were then to count around the circle in radians, the way I think about it is all the way around the circle is the circumference, and that is 2 pi radians. Which means if I were to instead only go halfway around the circle, so all the way is 2 pi, halfway must be pi. That means 90 degrees is half of pi. So now I'm going to count again. 0 pi, 1/2 pi, 1 pi. 270 would have to be 1.5 pi, or 3 pi over 2. And then 360 is 2 pi. You'll have to be able to know what the exact values of all of the radian measures are for every multiple of 90, every multiply of 45, and every multiply of 30 and 60. This is a unit circle. In a unit circle, the radius is equal to 1. If I were to count my way around a unit circle, but this time use increments of 45 degrees, it would look like this. 0 degrees, 45 degrees, 90 degrees, 135 degrees, 180 degrees, 225 degrees, 270 degrees, 315 degrees, 360 degrees. If I go back to radians, I'm going to start, and I remember that 100 all the way around is 2 pi, so halfway around is pi. And so if I look from here to here, that's 1 pi, and I've just divided it into 1, 2, 3, 4 quarters. And so the radian measures are 1/4 pi, 2/4 pi, which is 1/2 pi, 3/4 pi, 4/4 pi, which is right there pi, 5/4 pi, 6/4 pi, and I usually write 6/4 as 1.5, but I'll leave it 6/4 here, 7/4 pi, and then the 2 pi is 8/4 pi. The trig functions need to be memorized. So think of it like this. When you were in 4th grade, you had to learn your times tables. 3 times 3 is equal to 9. 4 times 12 is equal to 48. In pre-calculus, you have to learn your degree to radian trig functions, and we're also going to learn the sine, cosine, and tangent, and secant and cosecant and cotangent of them. That's at the end of the video. But for right now, if I say what's 360 degrees in radians, you should just say, oh, well, that's 2 pi. If I say what's pi over 4 in radians, you say, oh, that's in degrees, that's 45 degrees. You have to be able to go back fluidly, and if you're having trouble and you're stuck on one and you can't remember it, you should either count your way around the circle to get there, like I just gave an example of, or you can use the unit multiplier. And the unit multiplier is that 180 degrees is equal to pi. So if you just could not remember what 2 pi over 3 came out to be, you could multiply it by 180 divided by pi. The pi's cancel. 2 times 18 is 336. 360 divided by 3 is 120. And sometimes you'll use the unit multiplier, but you really want to work on being able to count your way around the circles, because you have to know where you're at on the circle in order to get your sine and cosine functions correct. Here's one more unit circle. I take the circle. This time I'm going to divide it up into angles of 30 degrees. And so we're going to look like this, and this, and this. And this is 0 degrees, and this is 180 degrees. And that means this is 0 radians, and this is pi radians. And so if I count my way around, I've divided my circle into 1, 2, 3, 4, 5, 6 pieces. And so 30 degrees, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. Those are the degrees. Since I divided the top half of the circle into 6 sections, I count this by sixths. Pi over 6 radians. 2/6 pi radians, and 2/6 is a third. 3/6 pi radians, which is a half. 4/6 pi radians, which is 2/3. 5/6 pi radians. 6/6, which is 1. 7/6. 8/6, which is 4/3. 9/6, which is 3/2. 10/6, which is 5/3. And 11/6. And I'm not going to do a separate one for 60 degrees, but you'll notice you may have it on it'll be on your assignment. Here's 1/3 pi, 120 is 2/3 pi, 180 is 3/3 pi, 240 is 4/3, 300 is 5/3, 360 is 6/3. So you will have to be able to count your way around a unit circle with all of these numbers. Think of it like memorizing your multiplication tables. It's just you're memorizing the trigonometry unit circle. Next, we're going to look at the 6 trig functions, although we'll just start with the first 3, sine, cosine, and tangent. And we'll start off with what you knew in geometry, that the sine of an angle is the opposite over the hypotenuse, and the cosine of the angle is equal to adjacent over hypotenuse, and the tangent of the angle is equal to opposite over adjacent. And we're going to use Greek letters for angles. This Greek letter I've put in these problems is theta, but you'll often see alpha or beta, or mostly alpha, beta, and theta. So now we're going to learn them differently for trigonometry. If I look at the unit circle, in a unit circle, the circle has a radius of 1. And this height is y, and this length is x. And so if I'm going to find the sine, cosine, and tangent of this angle theta, the sine is going to be y over 1, which is y. And the cosine is going to be x over 1, which is x. And the tangent is going to be y over x, which is actually sine over cosine. We'll learn that later. So now, in addition to this, you'll have to pull in together the special right triangles you learned in geometry and also keep track of sines. Like, if cosine is x and sine is y, in this quadrant, x and y are both positive, so the sine and cosine are positive. But in quadrant 4, the x's are positive and the y's are negative, so in quadrant 4, you have positive cosines and negative sines. In quadrant 3, x and y are both negative, and in quadrant 2, x is negative and y is positive. You can't just answer trig questions by knowing what the degrees are. You have to know where they take place on the unit circle, so you assign the correct positive or negative sign to go with them. Here are your two special right triangles. A 45, 45, 90 triangle is 1/2 of a square. And if I were to make the radius 1, which it is in the unit circle, and I were to solve this equation, this would be a squared plus a squared equals 1 squared. Now I know these two sides are the same length because if I cut a square in half, the two sides of the square are the same length. And if I were to solve that equation, I would get 2a squared equals 1, a squared is equal to 1/2, square root both sides, and if you simplify your answer, you get a is equal to the square root of 2 divided by 2. You will have to memorize that in a 45-degree triangle, the sides are the square root of 2 over 2 for the y value and the square root of 2 over 2 for the x value. Our other special right triangle, which is actually an equilateral triangle cut in half, but we're going to draw it on the unit circle in its standard position. So it's going to be right here. Now think back to an equilateral triangle. These sides are all the same. So the hypotenuse, or the radius, is 1. And the short side is half that, so that's 1/2. And if I were to use Pythagorean's theorem, 1/2 squared plus what squared is equal to 1 squared, and I'll speed this up and work this out in my head, I end up with a equals the square root of 3 over 2. And so what you need to know is that these are the ratios of sides in a triangle that has 30, 60, and 90 degrees. And especially important is that the 1/2 is always the shortest side, or shortest leg, and the square root of 3 over 2 is always the longer leg. That the 1/2 is across from the 30-degree angle, and the square root of 3 over 2 is across from the 60-degree angle. You're going to have to pause the video maybe and write those two triangles down. It's one of the more important things in this lesson. You have to be able to reference triangles to follow what we're doing for the rest of the time. So now we've established that the sine of an angle in a unit circle is y, and the cosine of an angle in the unit circle is x, and the tangent of an angle in the unit circle is y over x. In this class, we're going to add in the reciprocal trig functions. The reciprocal of sine is called cosecant. The reciprocal of cosine is called secant. And as a student, this always got me mixed up because the s right here goes with the cosecant and the cosine goes with the secant, and I just thought to myself, if the Greeks could have possibly used the same letters, it would have made it a lot easier for us to memorize which one goes with which. I don't actually know if it's accurate to blame the Greeks. I'm just blaming someone. Okay, so sine goes with cosecant, cosine goes with secant, tangent goes with cotangent. And now, if I remember that these are all reciprocal functions, they look like this. The cosecant of theta is 1 over y. The secant of theta is 1 over x, and the cotangent of theta is x over y. So you never want to find these other trig functions. Find your basics, flip them over to get your other ones. I know this isn't a lot of stuff. I wish you could have been in class to take 90 minutes to learn this instead of about 15, but now we're going to have a real problem. I want you to find the 6 trig functions: sine, cosine, tangent, secant, cosecant, secant, and cotangent for a 45-degree angle. Okay. The way you do this problem, first of all, is you have to be able to draw a 45-degree angle. In a 45-degree angle, it's right here. In a unit circle, the hypotenuse is 1, and these two sides are both the square root of 2 over 2. So now, sine is y, square root of 2 over 2. Flip it over to get cosecant. Cosine is x. Flip it over to get secant. Tangent is y over x, and if you take this over this, they're the same, so you get 1. Flip it over, you get cotangent, that's 1. Let's look at another example. We're going to find let's do a function that's in a different quadrant. Let's do pi over, let's do 2 pi over 3, 2/3 pi. So in my unit circle, I know 60 degrees is 1/3, and 2/3 is right over here, and there's 1. So 0, 1/3, 2/3, 1. I just divided 180 in half, so I'm looking at this angle right here. And since this is 120, this has to be 60. I know my longest side is across from the 60, so there's a square root of 3 over 2. My short side is across from the 30, so this is negative 1/2. And I know it's negative because I'm going left. And now I can say that the sine is the square root of 3 over 2, and I flip it over to get the cosecant. And my cosine is negative 1/2, and I flip it over to get my secant. And my tangent is this over this. The 2's cancel, so that becomes negative square root 3, and I flip it over to get my cotangent, 1 over negative square root 3. The steps are draw the circle, draw the triangle in the unit circle, label the triangle in the unit circle, and then answer the questions. Let's do 330 degrees. 330 degrees on a unit circle, the way I think about it is we're just 30 degrees shy of 360, so 330 is right here. When I draw that triangle, this is a 30-degree angle, so I know that if the radius is 1, this is 1/2, and this is the longer leg is the square root of 3 over 2. In this problem, the x is positive, but the y is negative, so it's negative 1/2. My sine is my y value, my cosine is my x value, and my tangent is my y value over my x value. And so if I take negative 1/2 divided by the square root of 3 over 2, the 2's cancel and I get negative 1 over the square root of 3. To get the cosecant, I flip the sine over. To get the secant, I flip the cosine over, and to get the cotangent, I flip the tangent over. If you missed class, you will find the homework assignment as a worksheet, and it is attached to the homework assignment on Schoology, and you need to fill it out, and you need to draw a triangle for every single little unit measure to get your answers. And the last example I'm going to give you is, what do you do with crazy angles? Like, let's say you had 180 degrees. Because here's 45, here's 60, here's 90, here's blah, blah, blah. But then I get down here, and these all make triangles. And all of a sudden, when I'm sticking straight out at 180 degrees, I have no triangle. But I do know that the coordinates of this point are -1, 0. And I know that my sine is my y value, and I know that my cosine is my x value, and I know that my tangent is y over x, 0. So the sine of pi is 0, the cosine of pi is -1, and the tangent of pi is 0. And if you're wondering where the heck pi came from, remember, all the way around a circle is 2 pi, and so halfway around the circle, or 180 degrees, is pi. And if I want to find the reciprocal functions, cosecant of pi, if I flip 0 over, that's undefined. Secant of pi, if I flip -1 over, it's still -1. And tangent of pi, if I flip cotangent of pi, if I flip tangent over, 0 flipped over is undefined. So at the 0, 90, 180, 270, and 360 marks, you don't actually have a triangle to draw, but you can draw where the line would end up at, write down its coordinates. The coordinate of this is 0, 1, the coordinate of this is 0, 0, and the coordinate down here in the unit circle is 0, -1. Those are the numbers you'll use to answer those trig functions.